All right, so in this example, ladies and gentlemen, you need to know how to graph the angle. That's going to be the first step. So as I mentioned, we always start graphing the angle in standard form with that as our initial side. Now, we notice that this is negative. The negative direction is clockwise. OK? We know that it is going in thirds. So just like I took my candy bar and I broke it up into thirds, I can take out my pi and break that up into thirds. Right? 1/3, 2/3, 3/3. Does that make sense? So therefore, I need to go -4/3. So I'll break the top up into 4/3. So therefore, my angle is 1π/3, 2π/3, 3π/3, 4π/3. Does that make sense? Initial, terminal. Is everybody OK with this? If you're not OK with this, you might as well ask now. Everybody's OK. All right. The next thing that people are having trouble with is the reference angle. Ladies and gentlemen, the reference angle definition is pretty clear. Only thing the reference angle says is the acute positive distance between the terminal side, or the x-axis, and the terminal side. That's it. It's just the distance between the terminal side and the x-axis. Yes?
What if it's past the side? Like, you know what I mean?
No. What do you mean?
What if it's,
Like below it?
yeah.
Well, same thing. Let's say I had like one of your, or let's say it was -5π/6. If this is 6π/6, 5π/6 would be 1/6 short, correct? Right?
Yeah, but say it was like, okay, the line's like going to go bottom. No.
Like here?
Yeah.
OK.
Like then where do you go? To the right or to the left?
OK. So remember, the definition of a reference angle is the acute positive distance or angle that represents the distance between the x-axis and the terminal side. So you have an angle here or you have an angle there. What is the only angle that produces an acute angle? Here, right? So it has to be there because that's acute. Reference angles are always acute and they're always positive. OK? So does everybody agree with me why that's my reference angle? Yes. So therefore, I gave you formulas, but I don't really like formulas. Ladies and gentlemen, how far past the x-axis did I go to get to my terminal side? Pi/3. So you'd say theta prime is equal to pi/3. Now, when evaluating, I think it's easier and it's OK if you guys evaluate, because it doesn't matter if you evaluate sine for pi/3 or sine for 60 degrees. It's the same thing. So it really doesn't matter. But we've taught about evaluating triangles with degrees. So we know what this is. We need to create a right triangle. So you create a right triangle. Now, what does that right triangle look like? That is 60 degrees. Pi/3 is equivalent to 60 degrees. Ladies and gentlemen, do we know how to evaluate for a 30, 60, 90 triangle? Yes, we have tons of examples of these, of 60 degrees, right? So the sine of 60 degrees. The sine of 60 degrees is going to be square root of 3/2. The cosine of 60 degrees is equal to 1/2. The tangent of 60 degrees is equal to the sine over the cosine, y over the x. So that's going to be square root of 3/2 divided by 1/2. Whenever you have a fraction divided by another fraction, we get rid of the fraction in the denominator by multiplying by the reciprocal. Whatever you do in the denominator, you do in the numerator. Any number multiplied by its reciprocal goes to 1. 2/1 times 3/2, those divide to 1. And you're just left with the square root of 3. Now, it's also important to note, what quadrant is my terminal side lie in? 2. Since we said the reference angle is always positive, we got to make sure we're evaluating for the quadrant that the angle is in. Since the angle is in the second quadrant, remember sine represents the y coordinate. So is y positive in the second quadrant? Yes. Cosine represents the x coordinate. So cosine is negative because it's to the left of the y-axis. So you got to make sure you plug in negative 60 or negative 1/2. Because technically, what I'm just trying to say is, taking the cosine of 60 degrees is the same thing as taking the taking the cosine of negative 4 pi over 3, if you plug that in your calculator, is the same thing as taking the negative cosine of 60 degrees. You'll get the same answer, which is negative 1/2. And then tangent. Since x is negative, a negative over a positive is going to do a negative square root of 3. So that would have been the final answer. So there's there's 4 questions on your quiz. Each question has 3 parts. Sketch, find the reference angle, evaluate. OK? If you don't know your 30, 60, 90 triangles, make sure you know your 36 triangles. Even though I've provided the unit circle for you, we have to know how to evaluate the 30, 60, 90. We have to know how to evaluate for the triangles before we can accurately use the unit circle. Because if you don't understand how to evaluate using triangles, you're just going to have to memorize the unit circle, which is a complete